We are very honored to have Jamie Brainard here from the USGS to talk to us about identifying critical minerals. Jamie's over in Washington, D.C., graduated from Penn State and has been working with the USGS to identify and do risk assessments on critical minerals. So he's a well-known expert in the area, and we are very excited to hear what all he has to present to us today. So thank you very much. Jamie, go ahead, hon.
Thank you. All right. I appreciate the opportunity to talk to you. I always thought these, when I was at Penn State, we used to have these kind of student seminars as well. I always thought they were really informative. So it's kind of fun to be able to throw one back. When I had talked to Sarah about what topics would be interesting to you all, the one thing that really came up was, everybody's throwing around the buzzword critical minerals, but not everybody's really getting into, well, how are you defining them? And since there's now a federal critical minerals list, and our organization was really the driving force with coming up with the methodology that created it, I'm pleased to talk to how we actually go about making that. Before we get started, I want to kind of just briefly mention what my center is at the USGS. So I work at the National Minerals Information Center, which is a subset in the Minerals Resource Program. So long before my time, we used to actually be part of the Bureau of Mines that was part of Department of Commerce. When that got shut down, we got rolled up under the Minerals Resource Program. So back in the day, we had a lot of economists, metallurgists. It was basically the full downstream to upstream portfolio. We're trying to rebuild some of that had been lost in the past 20 years. And so one of the big things is we're always looking to hire new people. And since you have a lot of new, young and early career people, I just want to say, I know we always have open rotation. So if you go to USA Jobs, that's where the US government, that's the way you have to go through to apply for jobs at the US government. But if you go to USA Jobs and look for the USGS, you'll find that there are a lot of postings out regularly that are for our center. And we're always looking for people from geology to economists. We really would love anybody who's got kind of a metallurgy or whatnot background. We have a major gap there. That'd be great. But anyway, so our center is really, we're this kind of mixed point between geologic data and actual mineral production. So what we're doing is we have a number of different sections, both on the country side and then on the commodity specific side. We have these experts who are out collecting data on how much is being produced of all these different commodities worldwide, the different process stages, the different process forms, and the mineral commodities sections and our global material sections, as well as just the support staff in the minerals information system. They're collecting all this data that my center, which is the Minerals Intelligence Research Center, is synthesizing and using to create things like the critical minerals list. So it's a really dynamic place to be in, because if you have a finger in every pie, if you're interested in geology, you're interested in economics, geostrategic interests, the whole 9 yards, it's worth looking at this. But anyway, that's where I come from. And so that's where, when we're approaching things like critical minerals, we're not just looking at the deposit information. We're not just looking at it just as pure mineral economics. We have a finger in every pie. So that's what's really nice about this world, is that you kind of have to have a broad set of interests, because you're going to be doing a little bit of everything. So again, critical minerals has been this really big buzzword. People have known that they've had vulnerabilities. If you're in a specific industry, you know it's really important to you. If you make beer cans, you know that aluminum is super important, right? Every different industry is going to have their own pet commodity that they're really interested in. And you see across the board, academics, government, corporations, they all are basically defining what they consider to be something that's important or vulnerability. And so you have this really hodgepodge set of, well, what is really critical? And what really comes out is it's kind of subjective, right? So it's depending on what your industry, what your focus is, you're going to be defining criticality as what's important to you. Now, we're at the US government, so what we're trying to do is take the broadest definition possible. And so what's really important for us is to say, okay, there's, even within the US government, there's two kind of ways you can look at it. What are materials that are maybe where there's vulnerabilities to the entire US economic sector, or there are the strategic materials, are what's really vital for, say, the US military to continue functioning. We kind of cover a little bit of both of those, but that's really the perspective that we have to take is, okay, how are we going to go about defining what is critical? Because we have to answer to a certain number of stakeholders. And so for us as the US government, it's basically the entire US economy is basically what we kind of consider our stakeholders to worry about. And so I'll come back to this particular slide, particularly because what we're going to see is there's a bunch of trends as I go through some of the metrics. So what's really for us when we start thinking about criticality, and I'm going to go through, well, how do you come up with metrics and how do you try to put numbers on this stuff? Because a lot of it's very subjective and it's a lot of things that you kind of intuit, right? You know that, well, if there's only a couple countries producing this, that should be a problem. But the real challenge is then, okay, how do you take that anecdotal knowledge and turn it into a quantifiable system? So for us, what we want to do is we take things basically a traditional risk assessment. So where we have risk is basically based off of 3 components. So risk has a hazard component, an exposure component, and a vulnerability. So the hazard component is how likely is something to happen? So, is a supply going to be disrupted? Is it very likely? Is it not likely because it's widely distributed? Exposure. So if something happens, does it affect me, right? So if you have your own domestic industry, maybe something getting shut down abroad doesn't really matter to you because you have your own domestic supplies. And then vulnerability is, okay, if something happens and there's a supply disruption, how bad is it going to be? So for our view, it's basically how much could this hurt the entire US economy? And that's how we're looking at vulnerability. So those different components kind of overlap and we don't really want to consider any one of them on their own. We think it's really important to kind of consider that interplay where they can either compound and make things worse, or if you have a very low exposure, maybe the hazard isn't so important because you're insulated from it. So we think it's important to have those. So that's one thing to keep in mind as I go through some of these metrics. Traditionally, the National Science and Technology Council, the European Commission, a bunch of different agencies in the past have tried to come up with very broad lists. And most lists usually focus on that hazard component, where is there a supply disruption because it's highly concentrated? They look at factors like that, but they don't necessarily take it to that next step of really expanding out. And the vulnerability in particular is one of the hardest parts to do. It's very new for us to try to come up with a way of putting numbers to this. And I'll go through why it's so hard. But it's something that industry. So if I was in the aerospace industry, I really do care about superalloys because they're the only material that if I don't have them, I'm out of business, right? So specific industries have cared about that economic vulnerability component, but trying to take this on the broad economy wide, that's been a new challenge for us. So we're just going to keep that risk assessment in mind as I kind of go through. So again, we have that hazard, exposure, and vulnerability. So in hazard, when we talk about supply hazards, there's really a whole big host of things that could factor into that, right? So we have geologic factors, market factors, governance factors, social and regulatory. And I'm going to kind of run through some of the things that we think about, or you maybe have kind of come across when you've heard about criticality. But keep in mind when we talk about each one of these, how this could be something that's going to be a real challenge to try to turn into something that's reproducible metric, and that's something that we can put in as being something you're going to base government policy around, right? Because it has to be transparent and has to be reproducible. So trying to come up with a quantitative metric, that's been our real goal. And that's one of the real challenges. So when we talk about geologic hazards, one of the things that people have kind of probably noted a lot has been that ore grades have been decreasing over time. Across the board, across most of the base metals, including some of the precious metals, when you look at the average mined grades, they've been decreasing. Now, production and supply has actually been continuing to go up, and that's because we've gotten better at mining. We're very good at mining low-grade ores at high tonnage, high-yield mining, but that is a concern potentially in the future, right? That the easy-to-get stuff has been kind of extinguished, and that we're going to have to start doing larger scale, lower margin minings to try to continue to supply the materials we need. So that's one geologic contributor. One of the other factors is that byproduct materials, it's something you probably have come across in the past, is that a lot of the materials that we consider really important for, particularly say the tech sector, things like gallium right now, germanium, rhenium, they're all materials that you don't actually mine themselves, you get out of mining something else. So gallium, most of that's coming out of your mining bauxite to make aluminum. And during that processing stage, you can recover that gallium. But what that means, though, is because you're not directly targeting that material, there's an added step in the supply chain. And so if it's something that's very tight and that, there's not that much excess that's in the mined host material. So rhenium is one of my favorite ones to talk about that. We're pretty good at capturing what rhenium is in that available mine supply chain. So if demand were ever to really go up for some reason, well, you now have a crunch where you need to mine more of that primary material to get in more of that byproduct. And so that's a big potential supply disruption because, hey, something could happen. And I'll talk about some earthquake issues where, hey, that could shut off a major supply of rhenium, for example. And then we have the market and economic factors. And this is the one where you've seen in a lot of the criticality models in the past, where they're looking at concentration of supply. So in this case, I have a periodic table wide, and I have it's China's share of global production. So this x-axis is going from 0 to 100% of global production that's being controlled or produced in China right now. And so what you see is for some of these commodities in the past 20, 30 years, you see gallium has gone to basically 96+% of gallium production is now within China. And so that poses a potential risk, right? Because A, just something could happen if all your eggs are in one basket, or if we're looking at things, again, on the global scale, and we look at things like geopolitics, well, if somebody controls a significant portion of that supply, they can exert outsized influence on that. And what we see is across the board, there are certain commodities where certain countries have a very large control and share. Now, some of these, you take South Africa and the platinum group metals, right? This is just blessings of geology, right? There are only so many bushvelds in the world. South Africa is sitting on them. No one's going to outcompete that, right? Because that's a world-class deposit. Same thing with, say, Brazil and niobium. They just have the richest, most massive niobium deposit on Earth. So of course they're going to have an outsized control on that. On the other hand, you get to some places like, say, China, where some of these commodities, it's not that China has more of them than the rest of the world, it's that there's been a concerted effort. So gallium, for example, is the result of government policy saying, hey, we want to have we want to be the world's controlling market player on this. And so they've gone out of their way to come up with ways to both increase production and to basically use state-owned enterprises to, nudge other countries necessarily out of business. So that's something that's really important is, okay, we know this is really important. So how do we turn this into a metric? And so one of the things we use is something called the Herfindahl-Hirschman Index. So it actually comes from the Department of Justice. They'll use it to talk about things like monopolies. And I'll show how we use it in a little bit later. But what that does is it basically is a measure of saying how concentrated is an industry. And so if something's super concentrated, we consider that to be more risky. If it's something that, say, like copper that's produced globally, everybody's producing at least some of it, that's a lower risk because the supply is very diffuse. But that's one of those geologic factors. There's also things like, again, the geostrategic issues, right? So when we looked at that high concentration of production, well, if a country wants to use those things for like trade barriers, where critical minerals kind of came to the forefront a couple of years back, there was a spat between China and Japan over a couple islands and access to them. And so China basically was saying to Japan that we are going to cut off your supply of these materials. And that's what really kind of brought this back into the foreground of, hey, some of these supply chains seem like there could be issues. That's where you saw this kind of new renaissance on critical materials that you hadn't seen really since the Cold War. But that's something to keep in mind is, hey, these things can be used as strategic tools. So it's another thing in a country's arsenal. So we have to keep in mind, well, it's not just geology. What are countries doing to kind of control these things? And that's something we also have to keep in mind. There's also just straight up governance can be an issue. So for example, South Africa has issues due to miners' protests, working conditions, and then union strikes, where just platinum can go offline for periods of time because of some of those mining conditions. And so that's where one of those things we have to kind of keep in mind is, hey, what are conditions like in those countries? Are they prone to having issues either due to labors or this is sometimes even just government crackdowns? There's also just simply, is there a government at all? And so one of the things you remember back, I would say remember back, but it was actually decades before I was born, but some of the conflict materials, so like Zaire, some of the civil wars back in the late 70s, where you had things like cobalt being highly disrupted during the civil wars. You also see in places like Rwanda, things like tantalum. That's actually why there's legislation. They call it the 3TGs. So tin, tantalum, and tungsten, where they're materials that are prone to being mined and used as conflict minerals. That's something to keep in mind is, hey, are these materials being sourced from less than ideal conditions? And is there a lot of control of the market under these conditions? Because you can't really base, and you shouldn't base a stable supply off of that. There's also just geologic factors that are kind of some of those stability risks. So in this case, geologic stability, right? A lot of the mining, things like porphyry deposits, they exist along some of these continental margins. That's why they formed, but it also means they're in some of the most earthquake prone regions on Earth, which means that we've seen it on several occasions where an earthquake happens, it'll cause a major slump. Some of these major mines will go out of business for a short period of time as they have to do fixing. Well, if it's in a place like Chile, that's 10% of world copper going offline for a period of time. So that's one of those things that we also have to keep. We want to kind of say, well, can you turn that into a metric? Because that is something that really is an issue. There's also social regulatory factors. So you have NIMBYism. You also will have countries that just flat out will be, no, we have the material, but you're not mining it. This came up with, there's uranium was being banned in Greenland. There's also rare earth materials. And there's a lot of controversy over whether or not those will necessarily be exploitable in the future. But that is something to keep in mind of, just because you have a very rich deposit somewhere doesn't mean you'll be able to touch that. And that's particularly an issue for the United States, right? Most of the United States has become highly dense and highly populated. Yeah, a lot of our mining's we have a lot of mining, but it's all in very rural parts of Arizona at the moment. A deposit being found on the eastern seaboard, well, that's not going to be mined, let's be honest. So those are things to kind of keep in mind. Then as we go from the hazard component to the exposure, right? So this is saying, okay, well, if one of those disruptions could happen, will it actually, do we face any risk from it? So this is one of the things that we do every year that's called a net import reliance. And so what this is doing is it's saying, okay, of US consumption of a given commodity, how much was being produced domestically and how much of consumption was being met by imports? So unfortunately, our import reliance for almost everything has gone up for the past 40 years, and as well as the number of materials that we're highly import reliant on. So you look at things like, say, gallium, we're 100% import reliant on. Rare earths, this is where it gets kind of weird. Yes, we started mining rare earths for a while there, but we have no ability to process that. There are plans underway, but if you can't process a material, it doesn't matter if you mine it. And we try to look at things in that bottleneck stage of, hey, if we can't mine it, or if we can't process it, okay, then we're just as dependent as we were before. We make a lot of shiny metal aluminum, but it's all from imported bauxite. So, okay, our reliance is on that imported bauxite. Same with, we mine a lot of lead, but that lead gets sent to Canada for smelting or elsewhere. So this is one where it's actually kind of easy to make it a metric because we actually have numbers on it. So this is really the major part of the exposure is, hey, if we're not import reliant, so if you look at something, you go way down the list to something, say like copper, hey, we're not as import reliant. If something were to happen in, say, Chile with copper, the United States is relatively insulated from it because you have a very robust domestic market versus, say, that gallium where we're 100% import reliant and China has 100% control. Okay, now you have a very high hazard and you have a high exposure. That's looking like a potential high risk. One of the other exposure things are, well, if you have a high degree of recycling, maybe you'll be okay, right? Aluminum has a ton of recycling. So that's great. The problem is a lot of the specialty materials that are the ones that we talk about the most and we'll talk, have flag as the most concern. They have very limited recycling because they're usually in weird mixed materials. They're in forms that really aren't that easy to recover versus, say, in the geologic state. So, and a lot of the end of life scrap is really diffuse, home electronics, things like that, and it's just gone. No one's getting the indium back from flat screen TVs, things like that, really. But that is something that factors into your exposure. And then we have the vulnerability, right? Which is, hey, if how much is this going to cost us if something happens? And so one of the ways you can kind of make yourself less vulnerable is having a substitute, right? One of the problems is we've gotten very good at engineering. And so what that means is if we're using a material for a product, it's probably because it's the best one for the job. And so you'll have things like, rhodium in your catalytic converter. Could you replace it with something like platinum? Yeah, it wouldn't work as well. And it's way more expensive. And so that's one of those things that kind of crops up with some of these substitutes are, yes, theoretically, you could talk about doing substitution, but if you do that, you're probably going to have a decrease in performance. And so that's something to consider. And again, the substitute cost, as I mentioned with say like rhodium, yeah, you can substitute platinum and palladium for each other, but okay, the ones with similar performance are similar precious metals. That's not really helpful. You're not going to say, okay, we don't have platinum. Well, maybe we can just put in some copper. No, unfortunately, that's one of those things in the vulnerability side that everyone likes to talk about substitution. Substitution for, at least in the short term for a lot of these things, doesn't really buy you an easy out. And then this is the part that's really important for us is saying, okay, how really important are you to the US GDP? And so this is for us has been the really big challenging metric to come up with is how can you kind of tie a commodity to the US economy? And so what we've done is the US Commerce Department, they have a Bureau of Economic Analysis. And so what they do is they actually go across the board to all these different sectors of the US economy. Maybe you've heard the term NAICS codes, where it's in a North American industry classification system. And so what they do is they actually look at some of the purchasing and intra-trade between all these different sectors of the US economy, and they come up with these big matrices of how they're all tying into each other. Well, what we're able to do is, okay, one of our very smart economists, who's actually was one of your guys from CSM, came up with a very interesting way to kind of tie in their purchasing. And so what we do is we take all of those interrelated industries, right? So in this case, I have aluminum. And so what we say is, okay, for all of those different sectors, from passenger vehicles, metal cans, construction materials, how much do they add to the US economy, right? So passenger vehicles is almost 1% of the US economy. So they add a lot to it. But what we want to say is, okay, but of your purchases of that material, so in this case, aluminum, we want to look at their profit margin and we say, okay, how does your profit margin compare to how much you're spending on the material? Now, if you have a very high profit margin and you're not spending much on that material, we say, well, it's probably not going to hurt you that much, right? So you take things like passenger vehicles. The aluminum going into a Ford pickup truck is not necessarily the largest cost that was in there. Versus, say, if you're making, beer cans, the cost of aluminum going up by double wiped out your entire profit margin. You're now underwater, right? So that's how we kind of look across this as saying, okay, of what you're spending, does a shortfall in that material basically make you go into the red? And then if you go into the red and are now out of business, how much does that hurt the economy? And so that's how we've come up with a way to try to quantify this. This is an absolute nightmare to map how these things go into the US economy. And one of the big challenges is, it's hard for us on the commodity side to map this in. We're also reliant on the Bureau of Economic Analysis, who they only do these surveys and try to collect this data every couple of years as well, because it's just as much of a headache on their end. However, this is a really cool new way to kind of include this. And this is really important for us because we can say, hey, some of these commodities that you're not considering under our risk factors might be really important to the US economy, and you'd miss a lot if you didn't include them. So bringing this back in, I just talked about a bunch of factors. And what you're kind of noticing is there was a recurring theme of there's a lot of these different factors in hazard, exposure, and vulnerability where you have commodities. This was a study that came out of our house a couple of years back where they went and looked at a bunch of different people's criticality studies, and they noticed the same commodities had the same kind of, you had a recurring commodities. So rare earths, the byproducts, they show up a lot. So, okay, lots of people have come up with these systems, but we needed to come up with the US government's. And so how did that come about? And so this is the part of the official US critical minerals list. This is kind of that story, and I'll kind of go through that. So we had been doing work prior to that. There's the National Science and Technology Council. They had a group looking at critical materials for decades before, or not decades, for a decade plus before, basically since that China rare earth issue. And they'd been working on screening tools, but it was definitely not formalized at the level that it's become now. But December 20th, 2017, this executive order dropped that said, hey, we need a basically to define what are critical materials and what are they. The fun part you're noticing is that December 20th, there were only a couple of us left in the building as that went out on Christmas, before Christmas break. So it was a fun mad dash. And we were given 60 days to come up with that. And, things have to be peer reviewed. So you had less than that. Since that time, though, we that next year in May, we had released that first critical minerals list. That was a simple methodology that I'll talk, but we've evolved a lot since then. There have been numerous other executive orders since then, as well as Defense Production Act activities. Basically, the government's been really starting to move on taking that information and saying, okay, we've addressed commodities that have vulnerabilities. How are we going to move forward? And then last year, we had an updated list, because one of the things that I'll point out in that executive order is this wasn't one and done. This critical minerals list gets updated every 3 years. So what was that executive order calling out? Basically, it said, hey, we know the United States is heavily reliant on imports. There's a dependency, there's a vulnerability. And so what it said was, okay, we're going to define a critical material as a non-fuel material that's essential to the economic and national security. So that comes back to who are our stakeholders. It's a very broad mandate, the entire economic and security health of the United States. And that there's a vulnerability in the supply chain, and a disruption or absence has significant consequences. So that was what's really important, is that was our order, was come up with a list of materials that meet that definition. And then again, it dropped right before Christmas, and we had 60 days to get that answer back to everybody. So our initial methodology, as I said, we had been working on things with that NSTC, and we had that HHI of looking at production concentration already on hand. And so that's what went into the initial materials list, right? Was we looked at disruption potential, where we looked at the concentration of production. And then we looked at the import reliance, which was that the NIR that I had mentioned that we produce every year. So that was easy to incorporate. So that was a good start. We got a good first go on that list, and it's transparent, reproducible. Everything that's on there, we can explain why they're on there. But then we're not going to rest on our laurels, right? That part of the mandate was we had to do this every 3 years. So that first one found 35. Now we're closer to 50 some, but that gets weird because all the rare earths got broken out. But what we've done since then is that's where we've implemented this supply risk as 3 components, where we've looked at all those components going in and turned them into metrics. And so that's where this, the most recent critical minerals list, why that's expanded, and that uses that methodology. So this is the methodology, right? In a graphical form that's a little bit prettier, right? So our hazard component was looking at that concentration of production. So that's that HHI again. But what was important is saying, hey, if concentrations of production is highly concentrated in a country that's very stable and is friendly, is that the same level of does that have the same risk of a supply disruption? And so what we did is we actually added layers to that HHI. So one was we went to the Fraser Institute out of Canada, and they do this annual survey of mining companies. And so what they do is they talk to mining companies and say, hey, how likely are you to be interested in opening a mine in these various countries, and why? So they go through governance, labor, safety, a number of different reasons why. Is there a risk of your mine being nationalized? And they rate countries of saying, hey, yes, we would open a mine there. And so we take that as a stability kind of metric of saying, hey, if mining companies are willing to put in the large investment of opening a mine in this country, it's probably not going to get shut down. So it's at least viable in terms of stability and governance stability. We also then came up with something we called a willingness to supply index. And what we did there was we looked at where the United States has strategic partnerships, security of supply agreements, things like that, and said, okay, these are countries where the United States has a long-standing friendship and military alliance, et cetera. These are countries who aren't really at any risk to, shutting off the tap, right? So you take Canada, who has one of the highest scores, right? It's a very long-standing partnership. If concentration of supply just happened to be very high in Canada, we're really not that worried about it because the tap being shut off isn't that high of a risk. So that's how that went into that hazard, right? Is that HHI and then weighted by individual information about those countries. The trade exposure, that was simply just that straightforward net import reliance again. So saying, hey, if there was something that would cause a disruption, does it matter to the United States? Unfortunately, for a lot of materials, yes, it does. But then you get to base metals, maybe not so much. And then the economic vulnerability was saying, okay, if a disruption happens, how bad of a hit is the US economy going to take? And that's where we use that vulnerability component that I went through a little bit earlier, where we're saying, okay, does an industrial sector basically go underwater because of a disruption in that material? And so when we put those together, these are the results for the most recent one. Yes, it says 2018. Unfortunately, to get global production data as well as just economic census data, we're always going to be a little bit slow on behind the most recent date, because getting global production just takes time. So we're always going to be looking a little bit in the past. So that's an important thing to keep in mind. And what you see is you have vulnerability on this axis, right? So how much of a hit does the economy take if you're absent? Your disruption hazard of, okay, how likely is a disruption to occur? And then the size of the bubble is how exposed are you to trade? So big bubble means we're 100% import reliant. Very small bubble means that we're relatively self-sufficient. And then overall, the color is those combined three components of risk. And so you have something like gallium, which is the highest risk score, right? So you have very high disruption hazard because it's one country who has mixed relations with the United States, controlling almost 100% of the supply. The United States is 100% import reliant on it. And then in terms of vulnerability, that gallium is going into basically every semiconductor now that's being produced. And so you have the perfect storm of those components. Something that most people maybe wouldn't have thought of is something in this area like aluminum, which actually is relatively high. And the reason for that is the economic vulnerability is off the charts, right? You have a lot of marginal industries in the United States that are producing things from aluminum that have very narrow profit margins. Whereas if the price of aluminum was to double, they're out of business, and huge chunks of the U.S. economy just go down if aluminum gets disrupted. You also notice that the bubble is very large, and that's because, as I mentioned previously, the United States doesn't mine any bauxite, so we're 100% import reliant on the precursors. So that's where having this three-component metric is really important, because that allows you to capture what are some of these risky materials that the simple anecdotes wouldn't have told you, right? Knowing that you're really economically vulnerable, and that there's a supply chain bottleneck that's not just the commodity stage, that's where we think the real strength of the way we've done this really shines through. So that being said, we're not going to rest on our laurels. That got us the 2023 list, or the 2022 list with the most recent data, but we're going to continue working on that. We're not done. We want to continue to expand and include things. So one would be, say, I mentioned how earthquakes can shut things down. We've been looking at ways of, hey, can you include natural hazards in some of these where there's a high risk of a supply disruption in areas where we have known hazards and can quantify what are the potential risks. There's trade exposure, looking at things like embedded trade. A lot of these commodities, rare earths are a good example. Hey, we mine them. Yeah, but we don't make the rare earth magnets. So, okay, if you don't define your system boundaries very well, you miss 100% import reliance that exists, right? Saying you mine a material but can't process it, you're missing a lot of stuff. So we're trying to incorporate those bigger factors as much as possible. And then we also want to just continue with that economic vulnerability, expanding out through those input-output tables to say, hey, how do the impacts of these events ripple through the U.S. economy? We had a good start, but we want to keep expanding it. And that is definitely a heavy load to do that kind of modeling. Now, what's also important is we talked about how we view criticality, but we also view mitigation in a certain related set of ways. When we talk about criticality, what we're really usually talking about is what's the risk of there being an imbalance between supply and demand at some point in the future. At the moment, so if we were to say demand for given commodity has been increasing in recent years, supply, particularly in the United States, has been decreasing. Right now, we're meeting that gap through the import reliance. Okay, how do we try to minimize that gap in the future? Because, well, exposure is one major part of that. If we're just looking at business as usual, well, okay, as we move into the future, we're just going to need to keep increasing imports. But maybe we can do things like increasing our manufacturing efficiencies, things like near form, additive manufacturing, where you're using just less of the material in manufacturing. So you're wasting less of a very precious commodity, particularly for things like super alloys. Maybe you can do some substitution. Yeah, as we talked about, it's really hard to design a substitute for today, but maybe a couple years out that might work. So with the cobalt in, say, batteries, there'd been a push to say, hey, maybe we can substitute a little bit more nickel in these over time. Things like that that are maybe not going to happen today, but towards the future, you might find through chemical engineering or whatnot, a little bit more viable substitution. And then the other thing is, hey, maybe we can just design things that are going to last a little bit long and keep longer and keep them on the shelves, maintenance, things like that. Then on the supply side, okay, the simplest one is, hey, maybe we could mine more of the material at home and increase domestic primary supply. Some things that's doable, something that's not, but that is obviously the lowest hanging fruit, but it has its own headwinds. Maybe you can increase secondary supply. Yes, recycling's hard for some of these materials, particularly electronic scrap right now. But for example, the Belgians are doing a really good job of coming up with ways to try to separate out mixed materials from end-of-life scrap, where it's basically throwing printed circuit boards in the pile and trying to get everything back out. It's daunting, but there's a lot of work going into it, and that would make a big difference on getting some of these scarce materials. And then it's also, hey, are we getting some of these? Can we increase our supply from friendly countries, right? So, okay, we don't have bauxite, but we're getting it from Australia and Jamaica. At the moment, that's a very friendly relationship. So, okay, as long as we make sure that we have a security of supply with very friendly countries, maybe we can just treat that as being as good as a domestic supply. And then the goal is, if you do that over time, you want to try to shrink that projected net import reliance. And then one of the big things is, particularly when we look at the strategic side, okay, if you have a smaller, gap, maybe you can do things like having strategic stockpiles, which is what the US military does. But it's also, as we saw with some of the supply chain issues with COVID, people are learning that just-in-time manufacturing is very efficient, but you might want to have a little bit on the shelf in case a boat doesn't make it on time or gets held up at Long Beach or whatnot. So all those mitigation strategies, just the real challenges, they all have a range of response times. And as we go from, easy things like trying to diversify our supply, buy from more countries, you can do that today, tomorrow. That's a political issue, not a technical issue. In reducing waste through manufacturing, people are doing that, but that's still, changing lines takes time. Recovering materials from end of life, you need to change how we handle scrap. The way we fixed with handling, like, say, lead from car batteries, you took government policy, but we're very good at doing that now. Redesigning, coming up with substitutes, that takes a long time because that's entirely re-engineering materials. And then rethinking of saying, hey, is there completely different technology? Maybe the battery of the future will be something like vanadium flow versus lithium ion for ground storage. Who knows? But that's again, maybe a decade out. But that's how we have to think about these things. It's not just being one basket and a simple solution that's ready. And that's where this is fun, is you have to be thinking about, okay, what can we do tomorrow? Turning on a mothballed mine. What do we do for 10 years from now? Well, opening a mine is a minimum of 10 years in the United States. So having that perspective. So really, what I want to kind of leave with it from our perspective and doing this methodology is basically, when we talk about criticality assessment, we're looking at it again in that tripartite risk assessment. So we want to balance these factors. So it's really important to say, as a whole, what is that risk of supply disruption? So you can do things, or you can have where one component can increase the risk, but you can mitigate it through other things, right? So if we have a material that we know has a high degree of disruption, say like the gallium, hey, maybe we could say increase domestic supply of gallium, so our exposure is much lower. So yes, there's a risk of that being disrupted, but it won't affect us. What's important, though, to note is that when we make some of these decisions, there's trade-offs. So again, I mentioned just-in-time manufacturing. It's very efficient. It saves money. However, it's incredibly brittle. One kind of notch in the gear happens, and you've disrupted your entire supply and stockpile. So those are the trade-offs you have to worry about in terms of your hazard and vulnerability. And really, what's important to note is when we're modeling all this risk, we're not predicting anything, right? And that's why we can use some of that backcasting data. We're basically monitoring the health of the system, saying where are there issues that there is a risk of something happening. What's important to note is risk is not prediction. It's not a probability. And I think that's where people think if you have a risk assessment like this, you can say, oh, well, there's something going to happen there in the next 5 years. No, it's just if something's going to happen, it's most likely to happen to this commodity. And what's really the goal here is to say, we're modeling this to say, what are the impacts of this happening, right? No one predicted that there was going to be a ship getting stuck in the Suez Canal. However, the European Commission doing its modeling could have said, hey, there's this many dollars of trade going through the canal right now. If something happens to the canal, what are the dollars that happen? We do this. Even the Energy Information Agency of the US does things like this to say, hey, Great Lakes shipping, what are the dollar values going through there? We want to basically be able to say, if something were to happen, how bad is it going to be? And that's where, say, adding that vulnerability was so important, because now we can say, yes, aluminum has an exposure issue and it's really high. However, we get aluminum or we get bauxite from a lot of countries. So pay attention to it, but don't freak out. That's why we want to have all this information, right? Is that we can take that information to policymakers, people who are doing all those kind of decisions. So I hope that kind of explained what we've been doing and how we're approaching this, just so when you hear the buzzwords of criticality, what are some of those metrics that go into that? And again, this is criticality as defined by the US government and for the stakeholders being the US economy. Other people are going to come up with their own critical materials lists. The European Commission has their own. Theirs might be similar, but again, they have their own unique considerations. And unfortunately, you can't do one basket that fits everybody. So it's just important to keep in mind when we're talking about, well, it's critical. Okay, who said it was critical and why are they saying it's critical? And so what was important for us is that we can show this clear methodology of saying it is critical because it could be disrupted. We are really exposed to it being disrupted. And if something happened, it's going to cost us a lot of money. And so thank you very much. I don't know how you do the questioning, but I'm happy to talk or go through anything with anybody who's interested. So thank you very much.
Thank you, Jamie. If you wanted to start, I believe Diane had a question for you in the chat. Otherwise, as people have questions, just go ahead and unmute and ask.
Here, let me I'm opening up the chat here. Okay, has the modeling been done by your agency or others considered how some of the US supply risk of import reliance could be mitigated if we start producing critical minerals from abandoned mine lands? Keeping in mind that there's congressional logjam in DC must be passed, as well as, yes, the Good Samaritan legislation so that nonprofits can step up. So yes, going through that, estimates in terms of quantity, there actually is a lot of work. So the USGS has an ongoing project called Earth MRI, where they're actually doing a lot of work looking at not just active deposits, but also relic tailings. There's a lot of work going on in the Mineral Resource Program to say, look and try to quantify how much extant material had been mined. We're starting to do some, from our house, do some of the back of the envelope calculations. I don't think they're necessarily going to be a panacea. However, where it does come out is, first off, we need to do a lot more work in characterizing what form these materials are in. A lot of the stuff, it's been slag pile, or if it's a tailings pile sitting out, okay, how much of the material that you want has survived the processing? Some of the material might be slag, and unfortunately, if they didn't have things like bag houses when they were doing some of the zinc stuff, for example, it's gone. But we are trying to do some of the quantification of that. Where I think where you're probably going to see the most opportunity is, it's probably not going to become an industry or a mining company of its own, but maybe it can help, we call it valorizing, right? Trying to make a profit on doing this, but maybe it can help fund remediation on some of these. So like the most vulnerable sites, okay, we have to treat it anyway because it's an acid mine drainage site or it's leaking cadmium, pick your material. Hey, but there's a lot of these materials of interest. Is there a way to basically, can we help fund the process of trying to fix it? I think that's probably where you're going to see more opportunities versus some of these mines where you're like, oh, there's a tailing pile, it's very rich, but it's from a mine in Colorado from the 1800s, where you realize that it was a very rich pile of tailings, but it's a month of output at some place like Bingham Canyon. The economies of scale, unfortunately, on some of these things have changed so much over time. And unfortunately, there's not a tailings pile, particularly if it was a precious metal mine, there's not a tailings pile left in the United States that hasn't probably been reworked at least once in the past couple decades because people are going to go back at least for the gold. Like, unfortunately or fortunately, gold, precious metals tend to drive everything. And so this becomes a real problem for some of these byproduct materials, like tellurium is one of these great examples of, okay, they electrowin, they go through anode slimes that are relics from doing copper processing to get tellurium, but they get gold first. And so if there's enough gold in there, and they're running it on their circuit and they're making money, they're not going to stop getting gold to get some tellurium. They only do it if there's extra capacity. And so those are some of the challenges that you see on some of these materials. But I hope that answers the question of, yes, there is ongoing work on trying to characterize, what is the material out there, and then just how much of it is out there. And then we can start, particularly in places like my house where we put dollar figures on some of the stuff. That's where we can start saying, hey, is it processable through current supply chains? So I hope that answers that. I see somebody's. Steve James, you have some. Oh, there you go.
Hey, thank you. Great presentation. Some of the minerals have very poor transparency, especially on a global basis. Do you work with intelligence agencies of the federal government to get a better idea of what's available in some of these countries?
So believe it or not, it's for a lot of the major commodities, it's actually less. It requires less cloak and dagger than that. Fortunately, a lot of these things, there's trade organizations. There's usually, it's finding out what's happening at, say, an individual molybdenum mine somewhere in rural China. Finding out their specific production is an absolute nightmare. But say finding actual output, usually that's readily on hand. Now, in terms of, we work with various agencies within the government, but our biggest partner is actually, yes, there's people in the IC who care, but there's actually the Defense Logistics Agency within the Department of Defense. They're basically the ones who hold on to the US government strategic stockpiles. They're probably our largest partner in trying to quantify, because they do their own shortfall analysis to try to say of, hey, what are materials that, the military in particular needs? And so they work kind of hand in glove with us. And that's, they're ones who in particular are trying to say, hey, are these materials being, are they sourceable in case of a material? Do we need to stockpile them because they're not in a friendly country? That's where, if you go through their security of supply agreements. So for example, there's something called the National Technology Industrial Base. I think I did that right. Or it's industrial technology base. So for example, the United States, Canada, Australia, and the United Kingdom, we basically treat each other's industries as being within our own borders. They're considered as being safe and secure. And that those are countries where there's zero hazard from our point of view, right? In terms of that supply will not be shut off because their factories are as safe and secure, and we treat them that way. So there is work, and there are work. There's, for example, trilateral agreements ongoing between, say, Canada, the United States, and Australia. There's a lot of work ongoing between partners that we can try to look at to say, hey, how can we meet our apparent consumption goals, particularly with friendly countries? So there is a lot of work happening on that level. Let's see, and hope that answered that. Let's see. South America is mostly green in the risk map because there's no real critical being extracted in the zone. Considering that many countries have supply disruption, local community issues, there's always places by copper, so the impact on the supply market is not significant. Is that like ignoring the elephant in the room? So that's where, in terms of that, if an entire country were to go offline, it would show up, right? So there is a certain amount of concentration issue in that HHI for those countries, but the risk in terms of again, this is where that changes from year to year. The risk of nationalization in a lot of these countries was very low. As we've been seeing, there's been civil unrest in places like Peru in recent years that has had an impact on copper. And as you'll probably see going forward, some of these things might change. Again, this is at the moment backcasting, but that is something that will change. And if you go through some of our historic data, you see there are other countries where you've had recent changes can cause risks to dramatically change. That being said, copper does have the benefit of having a widely distributed a widely distributed production. So we don't put that in that same, the HHI is relatively low. Where it does pose an issue, and this is one of the things we want to include and try to adapt our models are, hey, the byproduct materials. Yes, right now, uranium's split between largely Poland and Chile doing most of the production. But if their source material for it is also in a country that's highly concentrated, that's something we also need to consider of, hey, is the byproduct tied to something that also has a high disruption potential? And that's kind of that next step of trying to do an entire systems treatment. But as you can imagine, there's a lot of moving pieces. So every cycle we do this, we feel like we're getting better, but each time we have to come up with doing an entire new metric. And that's where there's a lot of work that goes into testing and validating some of this stuff. So the vulnerability was the last big change, but there's more to come, I assure you. I see Lucas Fale.
Yeah, hey, thanks, Jamie. Great presentation. I was wondering, are you doing any of this work for other countries, trying to understand what their vulnerabilities might be, their risks, as that might be a potentially interesting form of information for the US to understand?
So some of our metrics, so for example, the supply disruption potential is basically, it's country agnostic. Only that part where we did the willingness to supply really is US specific, but you can use that HHI. And so if you were to look at, say, the European Commission's version of it, theirs would have pretty similar results except for how friendly a country is. So you could adapt that readily. For us, it's been more a matter of we're trying to help or talk with partners who are trying to develop this. So the British Geologic Survey is doing their own, the European Commission's doing their own, Australia is starting to ramp up their own model. So we try to work with as many of these people. We don't try to run it for anybody, but it is certainly, we have lots of conversation, particularly with the countries where we have strategic partnerships. And so we're not going to be running, say, the Canadians for them, but we do talk a lot about, and particularly there's lots of work of, hey, what material sharing or information sharing can occur, particularly for those allied nations.
Gotcha. And from the non-allied perspective?
So for us, it's mostly been identifying the vulnerabilities. There is something that we do kind of try to do on the other side is consider where those strategic things that we consider a hazard or a risk, where are those strategic opportunities for a country? So if you were antagonistic, what do you control? So let's say you had the war in Ukraine going on. Hey, that's had a major disruption to neon. We kind of look at we try to reverse the situation and say, hey, what are those materials where a country could use them as an opportunity? Yes, we also look at what maybe they're vulnerable to, but we also want to say of, hey, if they're exerting outsized control, where are opportunities for a country that may not be the most friendly? Where do they have an opportunity to use them as leverage? Because again, we're the US Geologic Survey, so our first goal is to look at it from the US point of view. But we then also, we don't want to live in a bubble, right? It's not an isolationist system, but it's more understanding, okay, what's the US vulnerability? What's us and our friends' vulnerability? And who can use our vulnerabilities against us? And then kind of, okay, what are materials that the entire globe face a risk? And there are a lot of NGOs and whatnot who are trying to look at things from the global sense instead of being.
Yeah. Perfect. Thank you. And help.
Yep. Again, this is one of those things of, particularly if you're interested in this stuff, particularly if you're interested in the geostrategic levels, there's a book called War by Other Means that I highly recommend anybody to kind of look for, where it's kind of talking about this. It's bringing back a lot of the mercantilism from the 1700s, which is a term you haven't seen since then, but it's or seen since high school, but there's weird things happening in some of these supply chains where if you are interested in more than just say the geology or just the minerals processing, this is where it's a very fun field. If you're interested in geopolitics and whatnot, I highly recommend maybe checking either us or some of the NGOs, think tanks, other government agencies who are doing this, because it's very fun to put your finger in every pie.
Thank you, Jamie.
Let's see. Do you weight the criticality of minerals against each other to reduce the minerals criticality? So for minerals, there isn't domestic processing, but domestic mining may be rated higher since. So we don't rate, where what the at the moment, it's not a matter of does the impact of one impact the other. We don't have anything interconnected in that way yet. In terms of, say, the scoring, everything is the actual full criticality score. They're all ranked. So that's how you get that list from highest to lowest, is they're all weighted against each other in terms of just those three scores rank. But in terms of does, say, something happening to copper or moly affect rhenium, not yet. We'd like to, but again, we need more manpower. We're a very small group and it's a lot of lifting, but yes, that is something we really want to do. We know ore grade in mines is less and less. Do you consider any variables regarding difficulty of splitting? There's a lot of there's other groups that have been out there trying to look at things like what is the time for new mines to come on, and we've done things like looking at what is the life between exploration and operation. The problem is a lot of the exploration, things like that, precious metals have been really what's been driving a lot of this in recent years. We're not entirely sure how you turn some of this stuff into quantitative metrics, and there are other groups in academia who are doing that, but there is something to be said of trying to do something with quantifying, hey, what are, how many viable exploration sites in greenfield are out there right now that maybe could come online. That is something, we have lists of these things, right? But it's not a metric yet. So that is something that I know groups are trying to do, is say, how can you turn that into a metric? For the US side, we just go by the rule of thumb of a new mine right now from straight greenfield to a mine, that's 10 years if it goes through permitting and everything like that. Just everything being golden, it's 10 years for happening. Other countries, for example, Canada has done a lot of work trying to reform their permitting process to try to reduce that time. That's something, though, that that's on the regulatory side. The beautiful part about being at the USGS is we are a scientific agency, not regulatory. Means all these companies will talk to us because we hold their data very safe, but it also means that we're not regulatory. So everyone's willing to talk to us, which is very helpful for doing data like this.
Does anyone have any other questions for Jamie? Jamie, I really appreciate your time tonight. You gave an excellent presentation. I think it was really helpful to really understand what the USGS is looking at in terms of critical minerals. So I do appreciate that. Thank you very much.
Thank you. And again, if anybody's interested in this stuff, feel free to go to USA Jobs, check us out. If you found this interesting, maybe come working for us. Thank you guys. I really appreciate the opportunity to kind of share this.
Thanks, Jamie. I appreciate it. All right, we'll be in touch. Thank you. Have a good night, everyone.
Cheers.
Cheers.